So what we are working on is we are working on our applications of our quadratic functions, which you guys have done before. I know you've done it before because I wrote that note packet in 9th grade. I know you did it. Don't try to tell me you didn't. So we're just going to be kind of reviewing that stuff that we already did. So with your quadratic equations, when we're dealing with word problems, the majority of the time you get a downward facing parabola. Because generally when it comes to word problems, it's talking about a ball being thrown up into the air. So a ball follows, it goes up and then it comes back down, or it's a rocket that's being shot in the air, or a firework or something. Something goes up in the air and then it comes back down. A few times it is a quadratic that involves a minimum value, and it would look kind of like that, but those aren't as often. It's usually your upside down parabola. So when it deals with our word problems, we have two types of questions that it deals with. It deals with your intercepts, which is when it hits your x-axis. Those kind of questions will ask you, when does it hit the ground? If it's asking you when it hits the ground, you're looking for your x-intercept. You'd plug a 0 in for your y, factor, and solve. Other kinds of questions that they ask us involve your turning point. So that's either your max or your min. So it's asking, when does the ball reach its maximum height and what is its maximum height? Or how many cupcakes do you need to sell or get your lowest amount of profit, or something along those lines. So when you're trying to find your max or your min, you're really trying to find your vertex, which there is a little formula for it. To find the x value of your vertex, use the formula negative b over 2a. Does anybody remember what else we used that formula for?
Oh, that's part of the quadratic.
No. Well, yes, kind of. It's how we find our axis of symmetry. X equals negative b over 2a. That's how we find it algebraically if we need to. Because your axis of symmetry, if you remember, it goes right through the middle of your parabola, so it goes right through your max or min, which is why we can use that to find your x value of your vertex. And then the y value is just your y. What you would do is once you find your x, you plug that number in, it gets you your y value. So let's take a look at our first example here. We have an object is fired upwards with initial velocity of 112 feet per second. Its height in feet above the ground as a function of time in seconds since it was fired is given by this equation here. Find the time that the rocket reaches its greatest height. So we're trying to find its maximum. Since this is a negative, if we were to graph it, it would be a downward facing parabola. We're trying to find how long it takes to reach your maximum height there. How long does it take for that rocket to get up there? So when it's asking you about time, time is always an x value. So you would have to use your negative b over 2a. That's how we find the x part of your vertex. So our b value here is 112, but I make it a negative 112 because of the formula being negative b. What's our a value? Negative 16, so I have 2 times negative 16 in our denominator there. So let's see here, what do we get? 2 times negative 16. Negative 32. So let's divide those. What's negative 112 divided by negative 32? 3.5. So we'll take 3.5 seconds. So then it asks us algebraically determine the time when the rocket reaches the ground. So we're looking for when the rocket lands right back here. So that means we're looking for when the height of the rocket is back at 0, because that's when it reaches the ground. It's on the ground, not above the ground. So if we look at our equation, the part that represents our height is this part right here, the h of t. So since I'm looking for that to be 0, I'm going to replace that with a 0. And now we can solve for t. So 0 equals negative 16t squared plus 112t. What kind of factoring is this going to be? GCF, yes. What is our GCF? Not just 16. Negative 16, and then what else? T. So when I take out my negative 16t, I get t minus 7 inside the parentheses. So one of my answers is t equals 7 when I set it equal to 0. What do I get when I set negative 16t equal to 0? You would just get t equals 0. Because our negative 16t equals 0, we would divide by negative 16. 0 divided by anything gives us 0, so t equals 0 is our other answer. Which really, that makes sense, because this is saying at time 0, which would be at the beginning, the rocket is launched from the ground. Makes sense. When does the rocket reach the ground again, though? 7 seconds. You should have 2 answers, yes. Because 0 is when it first gets launched off the ground. They're looking for when it reaches the ground again. It reaches it after 7 seconds. All right, number 2, we have the height of a ball above the ground at time t seconds is given by that equation. When does the ball attain its greatest height? So we're looking for a time right now. We're looking for when it gets to the height. So when we're looking for the when it gets to the greatest height, we use our negative b over 2a. What is our b value this time? 140. And it's negative now because of our formula. And then what are we going to plug in for a? Negative 2. So that gives me a negative 140 over negative 4, which would be what? 35. So it's after 35 seconds it reaches its greatest height. Part B wants to know, what is that greatest height? So what do you think we should do to figure that out? Mm-hmm. Very good. So that gives me negative 2 times 35 squared plus 140 times 35 plus 1600. So what do we get? What's our height? That's not what I got. That's not what I got either. I got 4,050. I'm going to guess the 11,000, you forgot to put the negative in there. Okay. Oh, yeah, that makes it, yeah. And now, do we have anything to label it? Is it feet, meters, yards?
It doesn't say.
Doesn't say. So should we label it? No. If it doesn't say, don't label it. All right, so let's take a look at the back. We have a cliff diver in Acapulco, jumps from a cliff 17 meters above the water. His height in meter from the water, which is t seconds after he jumps, is given by the formula. How long will it take for the diver to reach her maximum height? Did you guys notice that the diver changes gender? His height. per maximum height. I just noticed that. Okay, so they want us to first sketch a quick little picture based off of our graph. So let's have you go into your calculators under y equals, and we'll type that in. So negative 4.9t squared plus 1.5t plus 17, right? Yep. And then we'll look at the graph. Which, looking at this graph, is this a very good graph? No, we can't even see where the maximum height is. I mean, I can see that the diver hits the water after like 2 seconds, but there's really nothing else. So we're going to have to play around with the window. So if you push the button that says window, X minimum, not when we're trying to get the picture to look good. Okay.
The picture is just a rough sketch. Does it have to be that specific?
Mm-hmm. Because I'm teaching a skill we're going to need later on. So our X minimum, we don't really need to go into negative X's because X is dealing with time. We can't go into negative time. So we want our X minimum to be 0, and 10 would work as a max because really it stopped at like 2 seconds. For our Y's, do we want to get into the negative Y's? No, because you can't. They're starting on a cliff. They're not going below the cliff. So Y min, we're going to start with 0. How high should we go? You think about it, they start at 17 meters. So we'll try 20. And then let's take a look at our graph. That looks a lot better. So now we can see where the maximum height is. And then they go down. So on your sketch graph here, that's what it should look like. It starts at 17. You hit the water at 2 seconds. Yes. You got to do negative b over 2a to find when does the diver actually reach their maximum height. So this would be negative 1.5 over 2 times negative 4.9. It's an ugly decimal. Yes. Not a nice number. Let's go 3. So what do we get as our 3 decimals? 0.153 seconds. Which I don't know if you guys are very experienced in your cliff diving, but it makes sense. If you're cliff diving, you want to jump more out away from the cliff and not really up too much. So the fact that they reach their maximum like 0.1 seconds after they jump, that makes sense because you're really kind of going out. I have. I did it in Cancun once. It was so much fun. Okay, number 4. We have the path of a golf ball for a new player is given by the equation there, where x represents the distance in yards from the player, and f of x represents the height in feet of the ball. Find the total number of yards that the ball travels. So, we got our little golfer dude. There he is with his little golf club. He hits his golf ball. So what are we trying to find? We're trying to find when the ball is where? We're trying to find when the ball lands here. We're trying to find the total number of yards that the ball travels away from the golf player. So we're trying to find it when it reaches here. So how do we find that? We're not going to use negative b over 2a. What are we going to do with our equation? We're going to set it equal to 0. Because if we set it equal to 0, that means we're looking for when it's on the ground. couple of different ways we can solve it from here. One is definitely easier than the other one. Does anybody have a suggestion of what we should do first?
Are we going to factor first?
No, not yet. No, not yet. We're going to subtract the 9.1 over. Because we're doing the method known as extracting the roots. Because I have this part right here, which is squared, I'm trying to get that on its own. I'm trying to isolate that, and then I can take the square root of both sides. So now we want to divide by our negative 0.015. So when I divide, I get 1,820 over 3 because it's a repeating decimal, so we should leave it as the fraction for now. When you did negative 9.1 divided by negative 0.015?
Yeah, you got 606.6.
And then hit math, enter, enter. Yeah.
So after you press enter, then you press math, enter, enter.
And it turns it into the fraction for you. Because it's a repeating decimal, the fraction form is what we refer to as exact value, and that's what we want to use. So we take the square root of both sides and we get plus or minus the square root of our fraction equals x minus 23.7. So what's our next step to get x on its own? Add the 23.7. So now it's just typing stuff into the calculator. So we have to get two answers. We have to do the 23.7 plus the square root of 1820 over 3. And then we're going to do the same thing minus the square root of 1820 over 3. So 23.7 plus the square root 1820 over 3. So we get 48.33. Well, we'll go 2 this time. But remember, that's in yards. The distance going out this way was in yards. Your height was the one that was in feet. So we got 48.33 yards. And then figure out with subtraction, 23.7 minus the square root of 1820 over 3. I'll give you a second to type that in. Let's have you give me the answer. It is a negative. Negative 0.93. So can we have a distance, though, of negative 0.93? No. So we got to reject that. So 48.33 yards. Which, from what I understand, is not very good in golf. I don't really know, though. I don't golf. Good call, yes. If you're only 48.33 yards from the pin, then yay. Isn't that the... I don't play golf. My dad would be so mad at me right now. The man loves golf. All right. Last thing we're doing today are quadratic inequalities. This is a brand new topic. Now, there are a couple of different ways of solving your quadratic inequalities, and this first page of notes is one way of solving it. I don't prefer this way of solving it, so we're not actually going to go through this. What I'm going to tell you is, if the way I show you doesn't make sense and you don't like it, I will go through this way with you, and maybe this way will make sense to you. But we're going to do the other way first. So let's go to the next page.
So we're just going to end up doing the same.
if what I do doesn't make sense, you might, but not everybody will. Okay, so when you are solving your quadratic inequalities, you want to do like you would for any quadratic. You want to get everything on one side and a 0 on the other side. So my example A here is already set up perfectly. I got everything on one side, my 0 on the other side. So what we're going to do is we're going to start with some factoring. So we're going to factor our x squared minus 5x minus 36. Will our signs be the same or different? Different. So I got x plus, x minus. And then what multiplies for 36 will combine to give us a 5. 9 and 4. Which one's going to be my negative? 9. So once you factor, even though it is an inequality, what you're going to do is you are still going to set them equal to 0 like you normally would. So we get x equals negative 4, and we will get x equals 9. Those numbers now are what we refer to as critical values. The negative 4 and the 9 are. So what happens with our critical values is we use them for a couple of different things. One of them is our answer has to go on a number line since it's an inequality. So the negative 4 and the 9 are the two numbers we use on our number line. And then because it's got the or equal to, I'm going to set up my two points. They're both going to be closed circles. So now what I have to do is I have to figure out, am I going to shade in between the negative 9 and the 4, or am I going to shade going to the outsides from the negative 4 and 9? So what I do is I set up a little test table. In the top of my test table, you are going to put your factored form of your quadratic. So in this case, it's going to be my x plus 4 times my x minus 9. And what we're going to do next is we're going to pick numbers that we're going to test. So you got to pick a number to the left of negative 4. So like, for example, negative 6. Then you need to pick a number in between these two. I always go with a 0 whenever I possibly can. And then you have to pick a number to the right of the 9. So I'll go with 10. And so then we're going to test them. If I plug negative 6 into this parenthesis here, I'd have negative 6 plus 4. I'd end up with a negative number. We don't care what the actual number is. We're just looking for what is the sign value of that number. If I plug negative 6 into this parenthesis, I'd get another negative number. When I multiply negative times negative, I would get a positive. So let's try the next one. If I plug in a 0 to the first parentheses, I'd get a positive number. When I plug a 0 into the second one, I get a negative. Positive times negative gives me negative. And then last one, the 10, when I plug it into the first parentheses, I'd get a positive. Plug it into the second parentheses, I'd get a positive. Positive times positive gives me positive. So once you have that filled out, you need to go back and look to where you factored. We want it to be less than 0. What kind of numbers are less than 0? Negatives. So I want that one. I want that one where it came out to be negative. That number that gave me the negative, which was 0, is in between the 4 or the negative 4 and the 9, so that's where my shading goes, in between the negative 4 and the 9. So the little table helps you determine where your shading is going to be. So then we do have to write inequalities to go along with it for our final answer. So when the shading's in the middle, your x is in the middle, so it would be negative 4 is less than or equal to x is less than or equal to 9. This one has the or equal to because it's got closed circles. Whenever it's shaded in the middle, it's always less than signs on both sides of your x. And then that's our final answer.
It says that less than or equal to 0. So, like, how could it be 9 if it's supposed to be less than?
Because if I were to plug in a 9, that value would be less than or equal to 0. It would actually be 0. Okay? So this is saying any values between negative 4 and 9, if you plug them in, you'll get a number that's less than or equal to 0. The table helps you determine where your shading is going to go, either on the outsides or in the middle. Since this was the value and 0 fell in between these two numbers, that's why I shaded where the 0 was. This other example, this one's going to have different shading. Let's try this one. So for B, we need a 0 over on our right side. So I need to move my 10x and my 8. So when I subtract my 10x over, I get a 2x squared minus 14x. What happens with our 8? They cancel. So then it's just greater than or equal to 0. This is a GCF factoring. What is our GCF? 2x, very good. And then x minus 7 is inside the parentheses. So then what are our two critical values here? The one everybody usually sees first is your 7. X equals 7 is one of them. What would we get over here on the left? We'd get x equals 0, because you would set it equal to 0 divided by 2. 0 divided by 2 gives you 0. So on our number line, we're going to have 0 and we're going to have 7. Those are our two critical values. What kind of circles on 0 and 7? Closed. So now we'll set up our table. Again, you put the factored form at the top of your table. So our 2x times x minus 7 goes up there. So now we have to pick numbers. So I got to pick a number to the left of 0. So somebody pick a number. -1. I got to pick a number in between 0 and 7. 1. And then a number beyond 7. 10. All right, so let's test them. If I plug in -1, I'd get a negative number when I multiply it times my 2. What kind of a number when I plug it into the parentheses? Negative. -1 minus 7 give me -8. So negative times negative gives us positive.
Stop there.
No. Stick with me here. All right, so let's test the 1. If I plug 1 in, what kind of a number do I get with the 2? Plug it in with a 7. So positive times negative is negative. So then if we plug in the 10, what kind of a number do we get with the 2? Plug it in with a 7. Positive times positive is positive. So again, if we look back up here and check, we wanted it to be greater than 0, so we wanted the positives. That's why we had to keep going. Sometimes you have more than 1. So since -1 worked, that means I need to shade to the left of 0 where the -1 is. And since the 10 worked, I have to shade to the right of 7 where the 10 is. It's all about the inequality. This wanted to be greater than 0. Greater than 0 is positive. The other one wanted less than 0. Less than 0 is negative. So then we just have to write our inequalities here. This is less than 0, so x is less than or equal to 0. Or, what's the other one? X is greater than or equal to 7. That's our final answer for that one. Okay, example 4. The number line graph given is the solution to which of the following inequalities? And no, you don't have to sit here and do all 4 of them out. Let's look at it first. What kind of circles do we have here? We have closed circles. So automatically choice 1, not going to be it because that doesn't have the or equal to. That would have to be an open circle. Which other one can we knock out right away? 2. That one would also have to be open circles. What are our two critical values here? The first circle is on -4. What's the next circle on? All right, so let's check this. Let's factor number 3 here. What would number 3 factor into? We'd have x minus x plus minus 4 plus 2. So I would get x equals positive 4 and x equals negative 2. Are those the same numbers? No. So that means it's probably choice 4, but what should we always do? Should always check. Now there is a way to check it in your calculator. So what I want you to do is go to your calculator, go to your y equals, and we're going to type the whole inequality in there. So it's x squared plus 2x minus 8, and then it's less than or equal to 0. Do you guys remember how to get the less than sign in there? We got to go to that word test right there. So you hit second, math, and then all your inequalities show up. We want choice 6. And then you type in your 0. So now we did mess around with the window for that other problem. So you want to hit zoom 6, and that gives you the normal 10 by 10 grid. Zoom 6 gives you the normal 10 by 10 grid. And then you can see our shading goes from where? Negative 4 to positive 2. Now the reason why I didn't show you that up above is because if you have to solve it algebraically, you got to remember to show us the work. The calculator is just for your check later on. So I want you guys to try number 5. Which of the following represents the solution set of the inequality given here? Let's have you try doing it in your calculator again, see if you can find it. So when we go to look at the graph of this, you should get the little line above the x-axis here. So where does the graph start? It looks like it starts at like about a half, because it's not quite 1. It's definitely not at 0, so it starts at a half and it ends at 3. So that means that one was choice 1. I had a lot of people choose choice 4. You would have had the shadings going separate if it was choice 4 because of the or. It goes separate. Yes?